Hey there, how are you guys doing? It is April 20th right now, and Wednesday is going to be Earth Day, April 22nd. So in honor of Earth Day, we're going to have an extra credit project. It's extra credit. If you're interested, you could do this. I'm going to give you a little explanation about it and talk to you about some natural resources. Okay, I have two soy milk cartons here. This one holds 64 ounces. This one holds 32 ounces. So this one holds twice as much soy milk than this one. Or it could be water, whatever you want to put in it. But they're 32 ounces and 64 ounces. And normally I buy this larger size, but last time I was out shopping, I got the smaller size. They didn't have this one in. Well, I won't go into all the details, but I don't like buying this size because I know intuitively that a lot more packaging is being used to house a unit rate of the soy milk. Okay, maybe per ounce, it takes a lot more packaging than this. But how much more packaging does it actually take? So I've worked out the surface areas, and I can show you and tell you not exactly how much, but close to it. Takes 271.8 square centimeters more. And the reason I have it written on this little sheet of paper is because this is how much more surface area of the packaging material it takes to contain the 64 ounces versus the 32. How do you figure all that out? Well, this is going to be what you'll be doing for extra credit. You're going to find some sort of rectangular prism, which could be like a cereal box, a shoe box, a carton. And I'm not going to ask you to calculate, say, the area here on these slants. We're just going to think of it as a prism, which would mean that this top would be completely flattened down. Okay, so just like a box, more or less. When I did my measurements, I went ahead and used centimeters. This is an old ruler we've had for years. I went ahead and used the centimeters because it's easier to get a decimal that way. You need to get 3 dimensions. You're going to need to get the width, the height, and the depth, how deep it is. You only have to do one object. I went ahead and did 2 just to kind of make it a little more interesting for us to see what it works out to be. Okay. This document is attached, so you'll be able to see all the calculations. But the question, of course, was how much more packaging is needed for twice the amount of volume, okay? And then you can see these 2 columns, 64 ounces versus 32 ounces. Now, whenever you have a rectangular prism, you have 6 sides, and the sides come in pairs, okay? Once again, we're just going to think that this top is the exact same size as the bottom. So you have a top and a bottom, a front and a back, and then a left side and a right side. Left and right are the same, front and back are the same, top and bottom are the same. So you're just finding 3 areas, doubling each of those for the 2 sides, and then adding them all together. So let's look at a few of these calculations. Well, doesn't matter which one we look through. So let's go ahead and take the one for 64 ounces. Its dimensions were 9.7 centimeters, 9.5 by 19.5. Okay, so 19.5 centimeters tall, 9.7 across, 9.5 for the depth. Alrighty, so you get the dimensions. And then I calculated the top and the bottom's area. 9.7 times 9.5, that worked out to be 92.15, 92 and 1500ths, and you double that, and you get the surface area of those 2 faces. Then the front and the back, 19.5 times 9.5, 185.25, double that, 300, oh, there's a typo on here, but it'll be correct when you get it downloaded, 370.5 centimeters squared, and left and right, the last 2 calculations, 19.5 times 9.7, 189.15, doubling that. Then you add it all up. So the total surface area of the larger container was 933.1 centimeters squared. The total surface area, and you can print this out or have it on another tab, was 661.3 centimeters squared. Okay, So what was the difference between those two values? When you subtract them, can we see that? You get a difference of 271.8 centimeters squared, which was this size, this amount, okay? But how much is the surface area when we got a total of 933.1? So it's hard to, these sound like large numbers. So what I did is I took a sheet of paper. So you have a sheet of paper. This is approximately 591 centimeters squared. So that's not quite enough. If you thought about it, could you wrap this sheet of paper and have enough? No. How much additional do you need? 342.1 centimeters squared. So these two pieces of paper put together would cover this box, this carton, okay? Doesn't take into account this extra. There's some lapping over. We're doing kind of a theoretical, not actual amount. If you wanted the actual amount, then you could take this all apart and lay it out and measure it, and then you would be able to get it more easily. Okay, so what is your extra credit assignment? Your assignment is to find the surface area of a carton, cereal box, shoebox, some sort of rectangular prism in your house. Okay, I'm going to encourage you to use centimeters when you do your measurements. How do you submit it? You can take a picture of whatever you measured. If it's a carton like this, take a picture of it and then take a picture of your calculations and send it to me in an email. Or you could put up a Google document, get a Google document, show your calculations, type out what it was that you measured, you know, was it a cereal box? Give the dimensions. You need to have the dimensions, show your calculations, submit your total surface area, and you can get extra credit for that. So Wednesday's Earth Day. I hope you guys have a great day on Wednesday, and these calculations are going to be attached to the posting. All right, hope everyone's doing well. Take care. Bye-bye now.